Hello, and welcome to Dear SQL DBA, a podcast and YouTube show for SQL Server developers and database administrators. I'm Kendra Little. This week's question is from a reader, and it's about how should they invest their time in learning about a performance tuning topic that sounds really cool. This is really worth asking questions like this because there's so much to learn in SQL Server that prioritizing what you're going to spend your time on is a really important task. Here's the question. Dear SQL DBA, I've been doing performance tuning for about 9 months now. It puzzles me that one type of index never gets much attention: full-text indexes. Are full-text indexes a feature that can really help performance? For queries like, I'm looking for like wildcard, blah, blah, wildcard. Queries with those predicates, application developers seem to love writing them. Or are full-text indexes quite the opposite and not worth investing time in? Best regards, puzzled about full-text. Terrific question. Full-text indexes sound like they index every part of every word. That's just because the name full text, full text index sounds like it's saying every word index or every character index. I think there's something in our brains that just make that connection because that's originally what I thought full text indexes would do too, but that's not exactly what they do. Breaking down the question, they're specifically asking about these specific problem predicates. Predicates that have these wildcards in them. I want to find blah, blah anywhere in a word. This is hard for traditional row store indexes in SQL Server to solve. Traditional, like our normal old row store indexes, if I have a text column with a sentence in it, it is going to order that column alphabetically starting at the beginning of the sentence. So if I'm looking for blah, blah somewhere in a word, and it's not, I'm not just looking for a word or phrase that starts with blah, blah. I'm going to have to scan that big old traditional index. But here's the dirty little secret about full text indexing. And this is not a secret, that Microsoft has not tried to perpetuate a fraud. This is right in the documentation. It's a problem kind of assumptions. Full text index helps with things like I want to find a word in a phrase. So I want to find a sentence where blah, blah is one of the words in the sentence. Full text helps with that. It also helps with prefix searches. I could say I want to find a word that starts with blah, blah, even if it's not the first word in the sentence. I could find words that are different forms of the word blah, blah. So perhaps, I haven't tested this one, perhaps blah, blah, blah is a synonym of blah, blah, right? But it understands kind of language. It knows similar words. It also can know about proximity. I want to find words or sentences where words are near one another. So full text search understands about language. It even has fancy features like stop lists and stop words to try to skip over joiner words that aren't that useful to search for, like a or at and things like that. It's about finding phrases. Full text search isn't about finding characters anywhere in a word or phrase. That's not a feature that it was built to make fast. A lot of people, when they want to do these creative predicates, are looking for characters with a wildcard at the beginning. And full text search just, isn't always a great fit for that. So for those folks who want to do full on like regular expression searches or find a character anywhere, there's things like Leucine. That's not a part of SQL Server. Leucine's a specialized searching application. And some folks find and use those. This is not an anti-Microsoft thing these days at all, because in the cloud, we can do everything. Microsoft has even built a tool available in Azure called Azure Search, where you can run Leucine queries against an Azure search index and do things like regular expression search in there. It's actually really fun to play with online. I wrote a blog post a while back called Wildcard versus Regular Expressions, Leucine Query in Azure Search, and had a good old time writing that post because Microsoft employees have put up sample Azure Search data sources in the cloud that you can play around with different Leucine queries using just a browser and try different regular expression searches as well as other kinds of searches. You don't have to log into Azure even. Like, it's completely free to play around with. It's really, really cool. So if you want to play around with kind of this cool next generation of search tools in the cloud, playing around with Leucine Query and Azure Search is really fun. Back to full text searches. It's the feature is technically called full text search, and then a full text index is part of the full text search feature. Let's talk a little bit about performance, because the question is about performance tuning. I have run into quite a few companies using full text search just in my life as a database administrator and sometimes as a consultant. And most of the folks I've run into who've been using full text are not using it on huge indexes. They've got some small part of their application that uses full text, and it works really well for them. They weren't calling me in to help with their full text search. In many cases, I'd look over their instance and look at their databases, and I'd see that there's some full text indexes, and I would ask about them. So how you liking these? And in many cases, they'd actually forgotten about them because it was fine. Oh yeah, I forgot we had those full text indexes because they didn't update them with super high frequency. They weren't super big, and they did what their job was, and they did it well. So that's actually a huge compliment to the feature if you think about it. Like, if you can actually set it and forget it, then that's like a rotisserie oven. It's kind of a cool thing. There have been some folks who I've run into who are more edge cases. I have had some experiences with databases using full text index on a very large scale. Think many terabytes of data in these very large databases, high insert rates, modification rates to the full text index, mostly insert rates in my case. And for these folks, performance was a really big deal. One of the things to know about a full text index is that it doesn't update synchronously when you put data into the table underneath it. This is a good thing. If every time I inserted a row that had many, many words in it, if it had to synchronously update every place in the full text index related to that, then my insert rate wouldn't be super fast, depending on, the size of the index and all of that stuff. The full text index is going to get the data a bit after it goes into the base table, and you're not going to notice this on a small index, really, right? It's really in these edge cases that are really, pushing the boundaries. You can have times where your full text index lags behind your base table. This can be tricky if you write your application in a way such that sometimes the base table and traditional indexes, row store indexes, get queried, and then some queries go to the full text index, because you might have a situation where a customer runs a query once and then runs a slightly different query and gets results back that don't make sense with one another. You can monitor the full text population. You can see how far behind it is. There's lots of ways you can do this. It's a specialized performance issue that if you really push in the limits of this, you need to know about. You also, in my experience, have to carefully plan the size of your full text indexes when you're getting into this very large database space, because like any other structure, you could get corruption in a full text index. just like a normal index. I mean, and this isn't the SQL Server's fault necessarily. The corruption could be coming from your storage vendor, could be coming from a filter driver between the operating system and the storage. There's lots of ways you could get corruption. There is, you can, in my experience, depending on your hardware and your version of SQL Server, you could have a full text index that's so large that it's prohibitive to rebuild it. In other words, sometimes when you have corruption, the way to really fix it is to recreate the full text index. And if you've got really giant indexes, that process could mean a big outage for your application. You can work around this by designing smaller tables, perhaps using partition tables and partition views and combinations. That's one of the things you need to think about in terms of full text indexing, though, is how long does it take to create the index? And are you in danger of getting to a place where that's a big problem? So full text search, kind of sort of summing up, is it something that we're still going to have? Because it is an older feature. One of the things with features that have been around for a while is sometimes we're like, well, is it going to go away and possibly be replaced by this newfangled stuff like Azure Search and that kind of thing? I actually think that full text indexing is definitely going to stay around. Like I said, there's a lot of people who've gotten into the feature and it's working really well for them. They just don't all use it at massive scale. But removing it from the product would be really, kind of a big problem for them. So I think it's definitely here to stay. I also think Microsoft has made good investments into it. They redid the feature essentially. There's major changes in 2008. And we've seen performance enhancements come out over the years. Even in SQL Server 2016, if you look at the what's new in SQL Server 2016, they added a new dynamic management view for full text search, and they even back-populated it back to a few versions. So it's a well-maintained feature by Microsoft. I don't know how well-maintained some related features are. In SQL Server 2012, we got a feature called semantic search that's related to this. So, I mentioned that with full text search, I could figure out proximity of words. That's one of the things that it does. Semantic search helps me kind of do bigger picture stuff like, what are the main phrases in a document? And can you find documents that are similar to this? Can you rank the similarity of these documents? And it's interesting. It's one of those features that dropped in, and then I haven't really heard much about improvements to it. I haven't heard much about the capabilities of full text search being strongly expanded in 2014 or 2016 or vNext. It just doesn't seem to get talked about anymore. And in terms of analysis, I know I haven't looked deeply into semantic search. Folks I know who have say it was a bit of too much of a V1 feature. It didn't have all the capabilities they wanted that they were getting currently from third-party tools. Now, let it be said that folks were investigating the native semantic search feature because those third-party tools weren't fitting all of their needs, right? They weren't so thrilled with them that they were looking for a greener pasture, that it just didn't seem quite ready yet. If you want to see an article about that, there's an article by Joe Sack called Exploring Semantic Search Key Term Relevance, where he checks how relevant certain phrases are in it. I would say, though, if you out there, if you're listening or watching the video or reading the article and you're using semantic search and you're happy with it, or you know about improvements that I don't know about, I would love to have your comments on the YouTube video or the blog post at littlekendra.com on this full text index episode, because I'm always eager to hear about other people's experiences. And there are times when Microsoft improves a feature and they don't publicize it in a way that's easy to find in a quick internet search like I was doing, right? So I'm interested to hear if you know about improvements to semantic search that I'm unaware of. So let's step back and revisit the question. How much time should you invest in learning full text indexes if, you're learning performance tuning in your first year? Honestly, I would say about an hour if you're not working with it, right? And that's where our questioner is. It's not in their environment. So I would say take about an hour, and the time that you've spent listening to this episode counts as part of your hour. What you want to do is just make sure you have notes and are familiar with the problems it solves, the problems it doesn't solve, like I've talked about, and just the information you need to identify if you come across a potential use case where full text index might shine. After that, I really wouldn't invest more time in it unless you find one of those use cases, and it could be a really big win, or you have a specific reason, like you're interviewing for a job and you can tell from the job description that they're one of those people who do use this heavily. You might want to spend more time on it there. But really, at this point, I would say, especially where you are, I would focus on learning about weight stats, learning about using execution plans to tune T-SQL and indexes, and row store indexes. If you're going to go out of that scope and you want to learn about new indexes, I would actually really look at column store. Cool new technology, lots and lots of recent investment, likelihood of getting asked about when you would use it during, interview questions, really, really rich. Knowing when to use in-memory, I would also say it's going to take more than an hour to use that in-memory indexes, just learning where it's at in different versions, use cases, risks, pros and cons. That's going to take several hours too. I would prioritize that above full text indexes as well, just because of that experience I've had where a lot of the folks who are using it, they don't really need help with it, right? So the amount of questions people have about should I use is more complex and is going to take more of your time to learn with more of these bleeding edge features in SQL Server 2. So I'm not saying that full text indexes are bad. I don't want to sound like I'm bashing here, because full text indexes are really good at what they do. It's just that I would mainly spend your hour learning about the scope of what they were designed to handle, and then move on to all these other cool topics that we've got to learn about in SQL Server. Thanks so much for joining me this week. If you are enjoying the podcast or YouTube show, I would really, really enjoy if you left me a review on iTunes. That really helps other people find out about the podcast, and it helps me keep going, recording each week. I do enjoy it. Thanks a bunch. I'll see you next week.